Ray Tracing in 1 Weekend. It's a free book, it's available online. And I started doing that, reading it and implementing examples. But that book recommends use C++, but instead of that I was using Zig. And it was a lot of fun. And by that sentence alone, you can guess that I'm very fun at parties. So I was doing that, it was fun, and I'm Python programmer, so I was wondering, is it insane to do that in Python? Is it insane to suggest other Python programmers to try to do toy ray tracer in Python? And this is how this talk was born. So demo time. Let's start with a Zig example. So I'm generating, and okay, so this is very impressive. Not exactly, but a little bit impressive. So what you see is 3 spheres. One is green, one is mirror, and one is so big that it looks like a plane. And it's physical, accurate lighting. Not really, but sort of good enough. So yeah, this is Zig version, and let's go to Python version. It's gonna take a while, so let's continue with slides. Where's my slides? Okay. So what? Sources like lamps or sun, or we pretend that sky is a light source, especially if it's cloudy like everything. And light sources emits light. It bounces all around. everything is vector math in this problem. So we have this, what's the go-to solution to speed up? Add slots. Right, so it's going to be x, y, z. Let's do that for a as well. So it's going to be big and 2. Let's try to run. Where's my terminal? Okay, running. A little bit faster. Not order of magnitude, so still not good enough for me. What we can do also, I know NumPy is fast, right? Let's use NumPy. We're gonna not use this. We're gonna tab free and instead of that, let's return array. Okay, start. Let's try now. Oh, it's failed. Okay, so I need to actually place all x's to all these to that, and all z's to second number of array. Let's run now. Oh no, it took a lot of time. So NumPy isn't that fast, is it? There's a problem. You're not supposed to use NumPy with very small arrays, because the overhead of Python will gonna hurt performance. So let's go back to vector. We need to go restore stuff. So it's gonna be that, right? 1 is gonna be this, and 0 gonna be x. Is working. Okay, we're back until working. Let's try. Yesterday I learned about my pick. Let's try it. Oh yeah, esoteric commands, and I think it's compiled. Yeah, we have it. So let's do that. Import main.
Are you launching the compiled?
I'm not sure. Let's
because it should have compiled into transpiled into C, compiled into executable file. So
let's move.
I think.
Okay, this and I was doing that means main food main bar. The reason, of course, is I don't use typing, so that could be a reason. But yeah, so I was stuck at this moment. I didn't know what to do, and the last attempt to survive was to use PyPy. And let's try PyPy. Boom! Nice. We can work with that. Let's add like. Let a little bit bigger resolution. Still reasonable. A lot of artifacts though, right? So let's add more samples per pixel.
Sorry, samples per pixel, is that basically number of rays per each pixel, or
It's
it's a bit more complicated?
yeah, but per so it's per edge, so it means like samples rays per pixel. But what I'm 2 is 2 multiplied by 2, so it's 4 actually.
Okay.
So okay, add more. I think we have time. We can run stuff.
We can debug your code.
It's a little bit boring to look at this number, but it's fast enough. Oh yeah, beautiful. It's possible, like it's reasonable to wait 12 seconds. You wait for GitHub Actions for half an hour. And you not complain. 12 seconds is good enough to actually have this loop of change code, look at the results, change code, or look at the results. So it's possible. It's possible. PyPy, thanks to PyPy, and we can actually do even better by cheating even more. So we can call Zig from Python. You should have expected Zig propaganda, I think. So let's use C types. Okay, so we don't need array anymore. We don't need to call this. We need to load our library, so it's gonna be ziglib, let's say. It's C types. Is it? Or I think it's this one. Okay, it's zig, it's zig out, lib, load library, so zig lib, what we're gonna, let's look at the code. So there we are exporting, and as you can see, I cheated a little bit at zig. I'm using threads. I'm making zig look better than it is actually. Anyway, we're gonna call this draw frame. It's gonna be that. I need main. Yeah, okay, this. So draw frame. I'm gonna pass this later. Now what I actually have this. I think it's win that, that. I don't need this part. Now I need to pass a pointer. There is a pointers in C type, so I think what's okay, it's gonna be void pointer. I think nobody's gonna complain. So screen surface. I'm using Pygame, and Pygame is wrapper on SDL, and there's a secret variable how to access actual like memory position of the surface. It should work. I'm not sure, but we have time for debugging. No, something is not defined. Okay, I don't need to bullet anything. Yay, it took 1.7 seconds. Nice as well. Let's go back to slides. So, wrong lessons to learn from this talk. Do not use CPython, always use PyPy. No, do use CPython. There's a problem with Python language. Not problem, but a fact. CPython doesn't have standard reference. It has reference implementation, which means that anything else is catching up. So use CPython and try others if it doesn't work for you. The second wrong lesson to learn is do not use NumPy. Pure Python is faster. Of course not. NumPy is faster, but there's use case where it's useful, and like having thousands of small objects and pretending to use NumPy is a wrong way to use the tool. And the third lesson, wrong lesson, which is gonna, for me, be harder to dispute, is do not use Python, use like Zig, C, C++, Rust, or anything like that's popular, that became popular 5 minutes ago. So there's a reason why Python is the most popular language in the world. I programmed with, I used Python professionally like for 10 years, and I always complain that it's slow because I'm quite negative person, quite complainer, I would call myself. But in my career, there was like 3 to 4 times when it actually affected me that Python is slow. Otherwise, it was just fine and easy to use, nice language, right? So do use Python. There's nothing wrong with Python until it is. Then use something else. Okay. Right? So good lessons. I was really impressed by PyPy's just-in-time compiler. It's almost the same as it managed to generate really fast opcodes and generate tracer image in really fast time. So it's really good. I'm really impressed. Kudos to the team. And NumPy is really good. But you need to know how to use it and what are downsides of NumPy and where you can burn yourself. And also the most important lesson, it is possible to implement a toy ray tracer using Python, and I highly recommend to try that. So that's it. That's my talk. If you have any questions, I think we have time. Yes. So please do.
Any questions?
Okay. You mentioned you are doing tracing from I to the sun, and let's say the right side of the sun. How it is done?
Like
yeah, in this example you mentioned that the tracing is done from the eye to the sun, but like usually the light comes to the eye.
Yeah, so that's
how do you do that mathematically, like in Python? What I didn't follow how you got the data.
So you need to read a book. The short version is you accumulate everything. So you start with a black color. So at the beginning, your ray has black color, let's say.
Yeah.
You shoot the ray. You hit the green thing, sphere at this point. And you mark that down, and you shoot another one. It goes to infinity. You know that you hit the sky, and now you trace back. So you go back. The sky, let's say, is full white. You go back. You see that you know your travel. Oh, sorry. You know your path the ray takes.
Yeah.
So you can go back as well. And you can calculate, like, sky is pure white, it hits your...
Actually, it's fine.
Okay.
There will be more interesting questions. I'll just ask after the talk.
Okay,
Because I
okay.
didn't understand me, you just came with some simple explanation which I understood, but that wasn't what my intended question was. I'll come and ask you.
Okay,
later.
fine.
Any more questions?
I can ask my question. Thank you.
Right. So there were these artifacts on the render, right?
Yeah.
Is there an easy to understand reason why they tend to coincide with where the shadows would be in correct coordinate?
Yes, I think so. So do we have? Let's look at. So there are artifacts and the shadows, which means a lot of rays hit the ground from the underneath of spheres, but some hit from various other places, and it marked as white. So there's not enough rays. If we generate more rays, the chances are that they will start to disappear. but then we cannot hit like 30 minutes per talk.
Probably in the dark area there's just a few arrays to get there, that's the reason.
Any more questions?
You mentioned threads in zip.
Yeah.
Why not use greenlets in Python and see how it feels?
I'm not that good at Python. I have never used greenlets.
Yeah.
So.
Makes sense.
So right now you just loaded the one frame, right? So
Yes.
have you tried like launching a game with with ray tracing?
So-
Python?
So what I'm doing is old school, and what like offline rendering solutions would do, like Blender, Maya, 3ds Max. Current computer GPUs have a special model for ray tracing,
Yeah.
so they can generate that in real time. I don't know exactly how that works, but they do have special unit to generate ray tracing. So it would blow my examples away. So thank God that my computer is too old, and I cannot run that. But yeah, there's real time. They're gonna try to sell you new GPUs with the real time ray tracing soon. So be prepared to pay a lot of money or ignore that. But the real time ray tracing is the thing that's getting more and more popular.
Yeah, yeah.
Can you go back to the image with the sphere and the ray?
Okay.
Yeah. Can you hit it with the ray?
Okay. I'm so proud of this.
No, no.
So
Yeah.
Okay, so yeah.
So you said that this pixel would be green, right?
Yeah.
Shouldn't it be white because the ray hits the sky?
Yeah, but it only hits sky after bouncing out of ball. So I do have
you trace back. You trace
yeah,
back.
trace back. So
Okay, I thought you traced back from the last object, or not? Maybe,
not
yeah, maybe I just don't know. But I thought that you would trace back from the very
so
last object. But
so there is no last object. Last object
Yeah.
is the sky, and when you can do it in another way, but it's easier to understand that. So the white, so you have the vector. Your color is a vector, so it's 1, 1, 1. You from the sky, you travel to the sphere. Sphere like takes away the blue and red violet, so now you have 0, 1, 0, and you pass that to the pixel or to camera, and this is how it becomes green.
Absorbs part of the light.
mirror.
And mirror just reflects, especially perfect mirror, which there is no in the world, but you can implement that in computer.
So it would have been white if the sphere wasn't green but was mirror.
Do I have that?
Coding time.
It would, but if you notice from this picture, sky is slightly blue, and also there's various effects of environment. So the plane underneath is gray, and I think there's some problems with displaying stuff on this screen. But the mirror just displays what it gets. I don't feel very comfortable defending physics, especially my buggy implementation of physics. So sorry.
It's good.
Okay, thank you. If you have more questions, ask personally. And thank you, Petras.